when we're talking about experiments, right? The first thing being the control group. All right, so when we have a control group, the participants are divided, well, first are any two or more groups, right? Typically called the control group and a treatment group. The treatment group receives a test. Think of when you, if we're testing, or when pharmacists or some kind of pharmaceutical company is trying to test a new drug, right? Usually they'll have different groups, right? One group will receive the treatment, the pill, the actual medicine, but the other group might not. They might receive just some pill that is just some sugar. It doesn't really contain any medicine. All right, so that is what's called the control group. Now, the reason that this needs to be done is to kind of counteract what is called the placebo effect. Right, is when the effectiveness of the treatment is influenced by the patient's perception of how effective they think the treatment would be. In other words, like if you know you're taking medicine, sometimes your mind will trick itself into saying, oh, the act of just taking the medicine might kind of make you think that you are feeling better. All right, so that's kind of the reason for these control groups. All right, you want to make sure that the medicine actually is doing what it's supposed to do. All right, so and again, a placebo, the term is a dummy treatment to control for the placebo effect. Okay, all right, now there are other measures that can be taken, something called a blind study or a double-blind study. All right, so and again, these are all measures to kind of make sure that there are that the experiment can be as successful as possible. Right, a blind study is one in which the participant does not know whether or not they're receiving the treatment or a placebo. Right, and this is kind of the most effective way to conduct an experiment. Right, when you don't tell them that they are having a placebo, you just tell them you're taking the medicine, and then you just observe the participants. All right, now a double-blind study is one in which those interacting with the participants don't know. So the researchers, in some cases, they don't even know if they're dealing with the placebo group or not, right? So the reason for this is to kind of avoid bias, right? Because if the pharmaceutical company has an interest in the medicine to be effective, then that might affect the researchers might get influenced by that, right? So sometimes they're not even told whether they're dealing with the placebo group or not the placebo group. Okay, so what we want to do next in this example here is we want to, so the example states we want to determine if exercise prevents colds. Okay, so that's kind of our mission. All right, so we want to set out to do something like this. All right, now we can do this a couple different ways, right? And we're going to break down, all right, let's say that I want to do this, and what would it look like if I did an observational study versus an experiment? All right, so thank you. All right, so let's say that we want to determine if exercise prevents colds. Right now, if it was an observational study, we would just, one way to do this, we would survey a random sample of people, and then we would ask them how much exercise they have. Do they do in a week? And then here, and then we might also ask, all right, have they been sick? In the past few months. All right, and if so, how often have they been sick, right? So, and then we would kind of try to make a connection from there, right? Now, again, this is kind of an observational study. We just go around and we ask people, right? Okay, now if this were an experiment, right, one way we could do this, we could say, all right, we gather a group of subjects, And then we could break it down, break group up into exercise and no exercise. All right, and again, this gives us, the idea here is that this gives us a little more control where we kind of are tracking them instead of kind of asking them. We kind of track their health over a period of time. All right. So now we could see here the question is the same in both cases, right? But we want to just kind of illustrate what the difference here is between an observational study and an experiment. Okay, now it's always nice to perform an experiment because you just have more control over the different variables, right? But sometimes that's just not possible. You can't just tell people to don't do any exercise, right? Unless of course they volunteer to be part of this study and be in that particular group. But then again, right, here we would like for these to be random, right? So you just want to kind of randomize our subjects. So again, this might not be feasible as well. Okay, so while the experiment is nice because we can control the, we have more control, in some cases it's just really not feasible because, you know, people might not want to volunteer for this experiment. All right. Any questions so far here between an observational study and an experiment? Okay. All right, so let's kind of move along here. Oops. All right, and again, if I am going too fast, you want to ask a question, just chime in on the chat. And then there's some buttons here that allow you can raise your hand, virtually raise your hand, or just kind of get my attention here, okay? Okay. Excuse me. So for this example, all right, it says, is each scenario describing an observational study or an experiment? Okay, so the first one, part A, it says, the weights of 30 randomly selected people are measured, right? So just looking at what the information that's given to us in front of us. So we just randomly selected people. So I'm gonna say here, this is observational study. Okay. All right, now if we look at part B, it says subjects are asked to do 20 jumping jacks, and then their heart rates are measured. Right now here we're actually, it looks like this is more of an experiment. Because we're asking a set of participants to perform something for us, and then we measure something there. Melody, you have a question? Okay, good question. How is it observational? Okay, so here, the reason why it's observational is we're simply, if there is nothing that we are doing, like we just pick some random people and then we ask if we can record their weights. And then that's what makes it observational. Now, if we were to say, all right, we're trying this new diet out and we want you to have a certain meal or eat a certain way over a certain period of time, and then we measured it, that would be more of an experiment. But if we simply just go out and we observe or we collect data, then that's observational. Whenever we start to perform something or ask the subjects to do something, then that moves it over to experiments. All right, does that make sense? Okay, all right. Okay, and then notice here in part B, right, how that makes an experiment. We asked our subjects to do 20 jumping jacks, and then we did a measurement there. All right. Okay. All right, so here, let's take a look at part C then. It says 20 coffee drinkers and 20 tea drinkers are given a concentration test. Okay, so now just based on that information, I would say, all right, that looks more like an experiment. All right, and the reason for that is we have two groups, and then they have some kind of task is given to them. All right. Okay, and then kind of that is what makes it an experiment, right? If you're asking people to do something, then you record them, then that would be record kind of some kind of data that would make it more as an experiment, whereas you just go out and you just start measuring it and you have no control, you exert no control over the question being asked or the data that's being gathered, then that would be more of just an observational study. All right, okay. Okay, any questions so far? Are everyone doing okay? All right, so as long as I don't see any hands up or anything in the chat bar, I'm gonna continue going here. All right, okay, so now let's take a look here. Identify confounding variables, right? So again, this idea of a confounding variable is something that we set out to record something or to find something out, right? A study. And we want to make sure that our study isn't being influenced by some variable that we're not accounting for, right? So now what does that mean? These can be a little tricky. It's not always obvious, and it just kind of require us to think through all the possible things that might influence our outcome, right? So for example, let's take a look at the first one here, right? So it says identify confounding variables. There is a high positive correlation that nations with many TV sets have higher life expectancies. What could the association be between number of TV sets and life expectancies? Okay. All right. So here, there are two measurements being made, right? In the terms of number of TV sets in a nation, and then life expectancy. All right. So one thing to keep in mind here, if there's a correlation, so one thing first to kind of define here, high positive correlation, is that there are the more TV sets, the higher the life expectancy. All right. So that is a high positive correlation, means that one of them goes up, one variable goes up, then so does the other one. All right. Now, another thing to keep in mind here is just because there is a correlation doesn't mean that that is the cause for the high life expectancy. All right. So just one thing to always keep in mind, just because they say correlation, we just want to make sure to understand that correlation does not equal causation. Okay. So then here we kind of want to think through, okay, well, if I want to say, all right, if the nation has a high number of TV sets, and the higher the number of TV sets, the higher the life expectancy, well, what else could be influencing the higher life expectancy? All right, now, one thing to keep in mind is we can think, all right, TV sets or TVs in general are a luxury item. So if you have a TV set, then you're probably, or the more of the population has a TV set, then that kind of leads more towards the society that they live in. It might be more well off, right? So a luxury item, so if more people have a TV set, then maybe the society they live in better healthcare, for instance, all right, or better quality of life. All right. Okay, so that might be something that might be affecting more than just a number of TV sets. All right, and that's kind of what I mean by a confounding variable, right? Just because you find two things that as one of them goes up, then so does the other, that doesn't always mean that it's caused by the variable that you're measuring. All right, you got to make sure and be aware, all right, what else could be going on? Okay, any questions so far on that example? Okay. All right. Again, just a reminder, if I don't hear from you guys, I'm just gonna keep going here, right? Yes, the response, well, based on perspective, well, yes, kind of. We just kind of, the idea here is that we want to kind of think through if we have just two measurements or one measurement and then another corresponding result, we just want to make sure that we always want to ask ourselves, all right, is there something that we're missing, right? Is there something that else that can be taken into account? All right, and what you'll find in most cases, there is always, it's very hard to just isolate two different quantities, right? In terms of when you're doing these kind of observations. Okay, does that make sense, Jorge? All right. Okay, so now let's take a look at the second one here. All right. So now for this one, we say, all right, children who watch many hours of TV get lower grades on average than those who watch less. Okay, now, again, here's where we have to be careful, right? Why does this fact not show that watching TV causes low grades? Okay. All right, so again, here we want to think, okay, always remember, correlation does not equal causation. So what are some other things that could be at play? All right, so maybe here we could say, all right, maybe one thing is access to extracurricular activities. All right. Or not just extracurricular activities, but maybe resources. All right. Where the reason, someone is watching more TV is just because they don't have access to maybe after school programs or extra tutoring that is available outside of the classroom, right? And instead they have just, TV as kind of their main source of entertainment instead of something else. All right. So this also might lead into those to be lower grade. All right. Okay, does that make sense? Any questions? All right. Okay. So now let's look at the third one. All right. So the third one says people who use artificial sweeteners in place of sugar tend to behave better than people who use sugar. So now here, does artificial sweetener use cause weight? What could cause this relationship? All right. Now, in this case, I think here, and I can speak from personal experience here. When I was younger, I used to weigh over 300 pounds. And the first thing I wanted to lose weight was I kind of switched over from, so started off overweight. And the first thing I did was I switched over from regular soda to diet soda. Right. So maybe the artificial sweetener wasn't the cause of it. I already came into it, I was kind of overweight. Right now, in this case, eventually you just kind of dropped off soda, but that might be another thing that we can look at, that it's a confounding variable, right? That it maybe wasn't the cause of it, but the fact that you were overweight kind of led you to think, okay, maybe I need to make some lifestyle changes. And one of those might be to switch from regular sugar to some kind of artificial sweetener. Right. Okay, any questions so far? We're doing okay? All right, so let's continue here. All right. Okay, so now why don't we take a look at this next example? Yeah, quick question. Go for it, Jorge. Is there a right or a wrong answer on these? I would say no, there's no like right or wrong answer. If you read that and then you could think of another reason. Again, the reason I came up with the third one was just kind of a personal experience, right? So if you kind of thinking through the problem, there would be no necessarily right or wrong answer, but another case, yeah, we might not all have the same kind of response to this, right? If you think of this and you think, all right, what other thing, as long as you can kind of justify and say, all right, this might be a thing that could affect it, then no, there is not necessarily something that is right or wrong, right? It's just kind of a matter of when we kind of analyze this, the goal of this is to determine, okay, we have this experiment that we have, what could be affecting our results, right? And that's kind of the goal, of to determine if we conduct an experiment, what are some things that that we're not accounting for, that aren't being measured, that might have a significant impact on our results. Correct, as long as we have some kind of justification to explain it away. Yes, I can do that. I'll try to slow down a bit. Okay. Okay, so why don't we try this? All right, you should see in front of you this next example. It says a professor wants to know whether the extra help she provides outside of class causes students to perform better on exams. She looks up the score of each student on the exam and whether or not each student attended office hours that week. She discovers that students who attended her office hours scored 15 percentage points higher on the exam than students who did not attend her office hours. Determine a possible confounding variable. Okay, so why don't you guys take a minute here, think about that question, look at the previous examples we did, right? And I would like for you guys, a couple of you guys, maybe chime in on the chat to see what might be a possible confounding variable for this situation that we have here. there's a blank file on Canvas, and I will post this marked up file after we are done here. Okay. What do you guys think? Any responses here for any confounding variables, something we are not taken into account? So that was the conclusion. Yeah, they did better. So here, I guess what we're saying is that what the conclusion that we want to make is, if you attended office hours, then you received a higher grade. You think it's a placebo effect? So they just felt good about attending office hours? Okay. Anything else? Anything else you guys might think of here? Okay, so one thing I do want to add to this is, well, double-blinded would be a type of experiment. Well, we'll get to that in a second in part 2. All right, now for this, for number 1 here, so one thing to keep in mind is that in some cases, maybe students who are struggling have trouble asking for help or seeking help. All right, usually in my office hours, I come across students that have like a little problem understanding one step here or there. Not for the most part, it's kind of just generalizing this here. And in some cases, students that are really struggling, they kind of have a hard time kind of reaching out and trying to get some help there. And that also, again, might be a confounding variable, something that we might want to take a look at. Okay. All right, does that make sense? Any questions on that? Okay, so let's see. All right, so now let's take a look at number 2 here. It says a study conducted on an allergy medication involved 100 patients who were split randomly into 2 groups. All right, one group received the allergy medication and one group received a placebo. No participant was told which group they were in. The study showed that those taking the medication were significantly more likely to report drowsiness than those taking a placebo rather than the medication. All right, so that's the setup of the experiment. And now let's see if we can answer these 4 questions here, right? So part A asks, all right, would you classify this as an observational study or a designed experiment? All right, now looking at what we have here, we have 100 patients split randomly into 2 groups. All right, so this looks more, instead of just going out and kind of observing data, this is some control that is being exerted over the patients here, right? So I would classify this as a designed experiment. Okay, so that's part A. All right, now part B, identify a possible confounding variable. Okay, so for part B, again, right here is what is one thing we might not be accounting for. All right, so here we could say, all right, so all right. So one thing that we might not be accounting for is people. Are these people, are these subjects here, are these volunteers, are other medications? Are they getting enough sleep? All right. So again, those are just possible confounding variables, right? Things we want to either measure or make sure that we ask, just kind of to make sure that our experiment is free of as much of these confounding variables as possible. All right, now let's look at C. So part C says, all right, would you consider the study to involve blinding? Explain. Now, definitely single blinding. For sure, right? And again, what tells me that is this part right here. All right, no participant was told which group they were in. So that is a blinding measure for sure. Now, as far as double blinding, it's unsure. All right, because it is not sure whether the researchers themselves know which group they are dealing with. Okay, but this for sure. It's unsure because it's from all I have to go off is what's given to me in this problem here. So here it says one group, no one was told which group they were in. So again, here it's unclear if no one, we mean the researchers or not the researchers, but definitely the participants for sure. But if we assume, so no participant was told, so that I'm assuming means the 100 people or the 100 patients who are taking the medicine. All right. It's not explicitly stating here whether the researchers knew whether they were dealing with the placebo group or not. Right. And that would make it a double blind, right? What would make it a double blinded if we're not sure if the researchers know what group they are dealing with, what group they are studying. Okay, so if it were double blinded, the patients would not know whether they would be in the placebo group or in the not placebo group, and also the researchers would not know which group they were dealing with. They would simply be sent in and say, all right, this group of patients is taking this drug, and then you want to kind of record their any kind of side effects that they may have. Okay, so it's unclear from just kind of what's stated here, right? It just said the participant was not told which group they were in. All right, if we were also told from this information here that the researchers didn't know, then we would say, all right, the researchers didn't know either, then that would be double blind. Okay, does that make sense, Jorge or Melody? Okay. All right. Did I answer D? Okay. D. All right. D. All right. So D, it says, were efforts taken to avoid confounding variables? I would say some. All right. It is helpful to have a control group. All right. Otherwise known as the placebo group. So there were some measures taken to avoid any confounding variables. All right. And again, just based off, we're given a short kind of description here. So we would say, all right, there were some that were taken. And we'd say, yeah, some were taken to avoid some confounding variables. And that would be this idea of a control group. Okay. The other questions before we move on? Okay. Okay, so let's do number 3 here. It says a study revealed that students who take math classes during the evening tend to have significantly higher success rates than those who take similar classes during the day. All right. Now, A, would you classify this as an observational study or a designed experiment? And then B, identify a possible confounding variable. All right, so I'd like to hear from you guys. Why don't you guys think about this and maybe chime in there on the chat, answers for A or B. Okay, good. I agree as well for A. You can say that's observational. What about B? Any suggestions for part B? Okay, so scheduling conflicts. Okay. All right. What about if some of these classes were okay? So maybe some kind of react to certain medications. All right. Now, what about some of these 8 a.m. classes? What have you guys ever taken an 8 a.m. classes? What effect does that have on your mood? Sleep deprivation. All right. Yeah, people are sleeping. All right. No one likes to get up early. People like usually, especially younger students. don't function the same. Okay. Yeah, good. So these are good possible confounding variables, right? Things that we kind of want to take into account. And yeah, no one shows up to you. You're telling me no one does show up to 8 a.m. classes. All right. Okay. All right. Good. Any questions so far before we move on from this section? So far, okay. So special ed students need more help, right? And maybe sometimes that's not available during the early parts of the morning. Okay, good. So I think we're kind of getting this, right? We kind of get, right, kind of to ask questions here. All right. So now what we've done here so far in this statistics part, we introduced new vocabulary, right? Just kind of how to talk about population, sampling. In this case, we looked at experiments, this idea of an experiment versus an observational study. All right. Now, what we're going to do next in our next section is, all right, once we have conducted an experiment, right? Now, what do we do with our data, right? We have this data here. How do I present it? How do I am able to make some conclusions from it? Okay, so I'm going to move on to the next set of notes here. All right, so in the next set of notes, we're going to look at, we're going to be describing data. So this is, we've gone out, we've done an experiment, right? Whether that be an observational study or a true experiment with control groups or whatnot. But now we have all this data, and now what do we do with this data, right? Okay, so our first step is to kind of create some visuals, right? So we're going to be describing the data, and then we'll get into numerical values that kind of represent, that are aimed to kind of describe our data. Okay, so let's take a look at our first example here. Okay, so here it says in January 2015, a random sample of 28 college students was asked to name their preferred web browser. Their responses are shown below. Okay, so here we surveyed, so it looks more like an observational study. And also, if you recall from last week, what type of data is this? Is this qualitative or quantitative? You guys remember the difference between both of those? Qualitative, good, Jorge, it's qualitative. Yes, yeah, good job, guys. It is definitely qualitative. Excuse me, my writing is still working on this writing on this thing. Qualitative. All right, good job. So it's qualitative data. All right, so observational study, we have qualitative data. So now we want to take this, right, and we want to kind of have a nicer kind of visual representation of this data. Now there are several ways we can do this. We could say, all right, using a frequency table, a bar graph, and what is called a Pareto chart. All right, so we're going to do 3 separate representations of this data. All right, the first one we're going to do is what's called a frequency table. All right, so just looking at this here, we say, all right, there are it appears to be 4 different answers given by these students. So you'd say, all right, the 4 different browsers that were used were Safari, Explorer, and Chrome, and Firefox. Okay, so to set up our table, we want to have it nice and organized here. So let's say, all right, wanna, yeah, for real. I wouldn't say about props, but yeah. So hold on, let me. All right, so I'd like to set up here my table, yeah, browser and frequency, and then I kind of set up my different values for the browser, right? The different parts of the data. So we'd have Safari, Explorer, Chrome, and Firefox. Okay, and then just kind of all right. Try to make it as nice as possible. I need a ruler here, but just kind of separating our data. All right. Okay, and then so browser, right? Our qualitative data here, the different qualitative data. And what I want to do next is I want to go to my data and then just kind of count up, right, how many of these students answered Safari, right? So I would just go in there and just kind of say, all right, Safari, we have Safari 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so just kind of count them up. I saw 10 of them, so I would run in for Safari to be 10. All right. All right, and then do the same thing here. We have Explorer, and it looks like for Explorer, we have one, two, three, four. Thank you. So we have 4 people that use Explorer. All right. Okay, and then we do the same thing. Now we count up the Chrome ones. Chrome ones are 12. Thank you, someone, for doing the counting there. 12, and then that means that leaves 2 for Firefox. All right, Firefox gets more love. I think that's a pretty solid browser. All right, so this is an example of a frequency table. All right, we have all our data there. It's essentially just a summary of this, right? Right here, it's just kind of hard to tell just by looking at the data. But now here we can just kind of refer to this and be like, all right, I can see all that data. I can say, all right, what's the most popular one? What's the least popular one? All right, I can answer questions like that. Okay. All right. Any questions on the frequency table? Okay. All right. So now let's take a look at the next one. We have a bar graph. Okay, so here for a bar graph, Okay, so we'll draw these axes here, right? This kind of horizontal and this vertical line here, right? And the vertical axis is going to be what's called the frequency it's going to measure, right? And looking at kind of my data, we'd say, all right, how much 12 is the highest number? So here maybe we go, all right. All right, and just kind of these tick marks here. The 12 isn't high enough, so I have what each tick mark represents a value of 1, right? So here, this is 1, 3, 4, 5. Okay. All right, and then I would set up my data down here. We'd have, all right, my data is Safari. Okay, and then looking at that, getting all this information from my frequency table, that goes up to 10. So it's all right, 10. Kind of fill that in from there. Okay, and then we would say, all right, what's our next piece of data? We have Explore. Right, and then that one goes up to 4. So it looks something like this. And let's just kind of fill it in. All right. And then our next piece of data is Chrome. And that one goes up to 12. Okay, and then here, the last one was Firefox. And that one is 2. All right. Okay, so this would be an example of a bar graph. All right, so pretty straightforward. Again, the qualitative data will always be on the horizontal axis, and then on the vertical axis would be the frequency, the amount that each of these shows up. Okay. All right. Any questions on the bar graph? Okay, so the next we look at, the last thing they ask us is a Pareto chart. Now, a Pareto chart is exactly the same as a bar chart, but not quite, right? We'll get into a pie chart, has its own name and it looks its own way. A Pareto chart is exactly like the bar graph, but it's ordered from highest to lowest. All right, so for example, let's say we want to, so we have the bar graph, and my Pareto chart is going to look very similar to this, right? Reverse, well, from highest to lowest always, yeah. So what makes it a Pareto chart is, so we're going to start with our axes. here, here. Actually, give me a second here. So we'll start with our axes here, and then this will be the vertical one. Again, always the frequency. It goes up to 12. Okay. So in this case, we look at our data, and we said in this case, Chrome had the most. So that would be the first one that would go in my Pareto chart. All right, so Chrome goes up to 12. All right, and then the next one would be the next largest value. So it's Safari. And that goes up to 10. All right, and then the next one would be Explorer. And that one goes up to 4. And then the last one, Firefox. And that one goes up to 2. Let's kind of fill this in here, make it look pretty. All right, and then we see the difference here, right? First one is a bar graph, and again, this could be in any order, right? And so a Pareto chart is just an example of a bar graph, but it has the highest data value first, and then it kind of decreases from there. Okay. All right. Okay, any questions so far? Okay. Yeah, pretty straightforward, right? So we're just kind of drawing some figures here. Now, the next one is a pie chart. Now, this one we won't do by hand. And again, if we want to create a pie chart, I guess we can always use Excel or some other kind of software, Google Sheets. But an example of a pie chart would be something like this. All right, so if you notice here, the pie chart has the, think of the whole pie as being 100%. And then if you notice here, yeah, it does look like the Google Chrome logo. If you look here, well, you can see, all right, Chrome is 42.86%. And again, how do we get these numbers? Here, these numbers, the percentage ones, right? You looking at our data, Chrome was 12 out of 28, 10 out of 28. Excuse me. Right, Explorer was 4, so 4. Two out of 28. And Safari, 10 out of 28. Excuse me. All right, so that's where kind of those percentages come from, right? And then that would be, this would be about 40%, the Chrome one, with 40% would get shaded in, right? And again, this kind of a little more challenging to draw by hand, but really after our geometry portion, we can kind of determine if we wanted to do this by hand, right? You would determine what would, right, that angle be, and then kind of draw the arc and the sector from there, right? But really for pie charts, we would use some technology to help draw the pie chart itself. Okay, all right. Any questions so far on our graphs? Okay, so why don't we let's stop here for today, right? We'll pick this up on Wednesday, same time, same place. If you guys have any questions right now, you can chime in on the chart. A reminder here: just keep track on Canvas for any announcements moving forward here. That would probably be the best way to figure out what's happening in this class, right? And you can find these files. We will not be going to class on Wednesday, no. So as of this week, like I mentioned on Canvas, we will be doing this online, and then the following week would be spring break, and then that's pretty much as I can say as what will happen moving forward. It looks like we're probably gonna have to do this for the next few weeks or so. There is homework. You can find that on Canvas. I will not collect any homework this week. I will collect the homework starting the week after spring break. All right. Yes, homework 7 will be due the week after spring break. Correct. All right, and I will assign homework 8 today. All right.